Scatter diagrams. Scatter diagrams show the comparison of two sets of data collected in pairs and plotted as coordinates. Let's have a look at an example. Here we have a scatter graph of temperature against ice cream sales. So these are the two sets of data, temperature and ice cream sales, and they're plotted as coordinates. So here are points that we've plotted as coordinates. Now if you look at the data, you can see that as the temperature increases, so do the ice cream sales. Now whenever this happens, when there's a positive relationship between the two, as one increases so the other one does, it's called a positive correlation. Let's have a look at another one. So this is a scatter graph of the price of a car against the age of a car. You can see that as the car gets older, the price of the car decreases. Now when this happens, whenever one increases as the other decreases, it is called a negative correlation. Now in this next example, we're comparing the math results of a class with the number of siblings each student has. Now, as expected, there's no relationship between the two. Therefore, we say there is no correlation. It is important to point out that it doesn't matter which way around the data is plotted, i.e. in this example, we could have had number of siblings on the horizontal axes and the math results on the vertical axes. So to recap, this shows a positive correlation. As the temperature increases, so do the ice cream sales. That is a positive correlation. And this one, as the age of a car increases, its price decreases. So when, for example, looking at this point shows that it is very old, the car, and the price is low. And then that is a negative correlation. And in the final graph, you can see that there seems to be no pattern at all. The points are all over the place. And as expected, we wouldn't think there would be a relationship between the math results of a class and the number of siblings each student has. So this, we would say, is no correlation. Line of best fit. If there's a positive and negative correlation, you can draw a line of best fit. Let's see how to do that. What you need to do, you need to draw it so that it passes through the majority of the points and roughly the same amount of points on either side of the line. So for example, so there's roughly the same amount of points both sides. Now you'll notice that the line does not have to go through 0, 0, as long as it covers all the points, so it goes up as far as it needs to and goes down as far as it needs to. You'll also notice that there sometimes are points that are too far away from the line. For example, this one here, this is called an anomaly, and it is a point that does not fit the pattern. The line of best fit allows you to make predictions for values not plotted. For example, this was a graph of umbrella sales against rainfall per month. You might be asked, for example, if you had a rainfall of 60 millimeters, what would be the predicted umbrella sales? So what you would do is you'd go to where 60 millimeters would be on the vertical axis. Let's say it's here. Then you would draw a line across to where it hit the line of best fit, and then you would follow it down to the horizontal axis, and you would read off this value here. So what we'll do, we'll have a look at this with some actual values. So we're going to have a look at average monthly temperature with sales of hot water bottles. So first thing we'll have to do is to draw the grid. And all we're concerned about here is the two pieces of data. So we have temperature and sales. We don't care what month they occurred in. All we're concerned about is the relationship between the two pieces of data. So what we'll do first of all is we'll plot the first point, which is 3:32. Then the next point is 5:29. Let's go along 5:29. And so on, plotting the rest. 14, 12, 15, 16, and so on. So my points look like this. So now try and get your line of best fit roughly so that there are the same amount of points on either side of the line. So let's have a look. Let's draw it here. That looks about right. Now this line of best fit slopes down the page, which is what you'd expect because there's a negative correlation between average monthly temperature and sales of hot water bottles, as you would expect. So as a small temperature is recorded, a high water bottle sales is recorded, and we have a high temperature here and low hot water bottle sales. As mentioned before, if you wanted to estimate the sales of hot water bottles when we had a certain temperature, for example, estimate the hot water bottle sales when a temperature of 7 degrees is recorded. So we go to 7 degrees C on the horizontal axis, which is here. We draw a line up to where it hits the line of best fit. Then we go across and we write down that temperature there. And we can see it's just above 26, but they want an estimate, so we'll give the answer as £26,000. Now it's your turn to answer a question. Pause the video and then have a go. How did you get on? Here are the answers. If you answered any of it incorrectly, have a look back through the video and then have another go.